All right, so the first thing we need to know is what are the angles? Like we said, we're going to use the apothem to help us find this area, but we don't know how long it is. The only thing we know about this octagon is that it's regular in that its side lengths are 6. So that means every side is 6 feet long. So if we want to use trig to solve this, we'll need to know another angle besides this 90-degree angle. So in our last unit, we learned how to find what the measure of one angle should be in a regular polygon. So since this is an octagon, we know it has 8 sides. We can use our equation 180 times n minus 2 over n. So that's going to be 180 times 8 minus 2, which becomes 6 over 8. And when we calculate that, we should get 135 degrees. So this part is from last unit. And so what we know about that is every interior angle of that polygon is 135 degrees. Excuse me. So then when we draw in the radii though, the radius is going to bisect that angle. So radius bisects interior angles. So if I want to know this smaller angle here, it's just going to be half of 135. So 135 divided by 2, I think that is 67.5 degrees. All right, so far we figured out that each interior angle is 135, and then that little angle is going to be half of it because these will both be 67.5 degrees. Okay, so now I'm going to focus in on just this one big triangle, and then we're even going to look at the smaller 2 right triangles it's made up of. So if we look at that big triangle separately, just to consider what we know about it, we know that this is 6 feet. We know that this angle is 67.5 degrees. We know that this angle is 67.5 degrees. We know that it has a height, which we call the apothem, that makes a right angle with it, and I'm going to label that A right there. And then we don't know anything else. We don't know the radius. We don't know how long this radius is. We don't know anything else about this. But this height, since these are both 67, I should take that back. Something else we do know is that this triangle is isosceles. And when we drop, bless you, when we drop this height, we end up with 2 congruent right triangles within this bigger triangle. So this right triangle is going to be the one made by the apothem and the radius. I'm going to kind of color code it on both of those. All right. So now, if we just look at this right triangle, we could use trig to figure out the length of the apothem. I'm going to re-sketch my right triangle over here. We said this is the apothem, this is the right angle. This angle is 67.5 degrees. How long is this side right here? Yeah, this side's going to be 3 feet because it's going to be half of that whole side 6 feet. So we're looking at half of this big triangle. All right, so if we think about this, this is our angle of interest. We have an opposite side and an adjacent side, and we know if we're talking trig, SOHCAHTOA, so sine is opposite and hypotenuse, cosine is adjacent and hypotenuse, tangent is opposite and adjacent. So we want to use the tangent function because we don't know this radius, which is the hypotenuse of that triangle. So we're going to do the tangent of 67.5 degrees is equal to the opposite side. In this case, this is our apothem. so I'm going to write A for apothem, over the adjacent side, which we know is 3 feet. And we talked about this a little bit in our warm-up, but when the variable's on top, we could multiply both sides by 3 to get 3 times the tangent of 67.5 should equal the length of that apothem. All right, so let's plug that in our calculator and see what we get. All right, so we're gonna plug in, and we wanna make sure we're in degrees. So if you go to mode, if you've like reset the memory in your calculator since our trig unit, double check we're in degrees. And then you can go to second quit. And we're gonna type in 3 tan 67.5, and we should get 7.243. 7.243. All right, so that's gonna be the length of our apothem. So we're almost, we don't know the area yet, but we know how long this is. All right. So now if we go back to our entire triangle, like that big triangle, we now know its base. So I'm not talking about the right one, but I'm going back to the isosceles one. We now know its base is 6. Its height is that apothem we just found, which is 7.243 feet also. What we remember from yesterday, no doubt, is that the area of a triangle is the base times the height divided by 2. So the apothem of this octagon is the height of the triangle. So we're gonna do 6 times 7.243 divided by 2. Let's see what we get. I got 21 and some change, 21.728 if we round, 21.728. So the area of the triangle is about 21, sorry, I know I'm off the screen here a little, 21.728 approximately feet squared. So that's not the area of the entire octagon, but that's the triangle. That's 1/8 of the octagon because it's a regular triangle. So the last step in finding the area of the octagon is to just multiply the triangle area by 8, because each of these triangles formed by the radii, each of them are going to have this area of 21.728. So if we multiply that number by 8, we get about 173.823. So the area of the octagon, I'm going to write OCT down there. I know I'm like writing in the corner of the paper, is going to be this times 8, which is approximately 173.823. Oops, 24 if you round correctly. Sorry, 24 feet squared.